Integrate from 2 to 3 x times the quantity of 3 minus 5x divided by 3x minus 1 times x minus 1 the quantity squared. The degree of the numerator is 2. The degree of the denominator is 3. Therefore, we do have a proper rational function. I'll distribute in the numerator 3x minus 5x squared, but I'm going to leave the denominator factored. That was actually kind of a nice thing that our author did for us. And I'm going to set that 3x minus 5x squared over 3x minus 1 times x squared minus 1 the quantity squared equal to some fractions, one of which will have a denominator of 3x minus 1, but you may recall that x minus 1 quantity squared is an irreducible quadratic. Therefore, I need to have one fraction that has a denominator of x minus 1 and another fraction that has a denominator of x minus 1 the quantity squared. Each of these denominators, or bases of denominators, is linear, so we need constant numerators. I now have a over 3x minus 1 plus b over x minus 1 plus c over x minus 1 the quantity squared. If we imagine what would happen if we got common denominators and then set an equation just of the numerators, then we can see we would have 3x minus 5x squared is equal to a times the quantity of x minus 1 squared plus b times 3x minus 1 times x minus 1 plus c times 3x minus 1. If you saw the previous video, then you'll know at this point we can go two different ways. In fact, the way this one's going to work out, we're going to need both. We're going to use both. Distributing on the right-hand side and collecting like terms will give us the equation 3x minus 5x squared is equal to the quantity of a plus 3b times x squared plus the quantity of negative 2a minus 4b plus 3c times x plus a plus b minus c. Equating coefficients of like terms on the left and right, we can see that negative 5 is equal to a plus 3b. 3 is equal to negative 2a minus 4b plus 3c. And since there's no constant term on the left, we know that 0 must then be equal to a plus b plus c. A plus b minus c. Now this is of course a system of three equations and three unknowns. We can solve this using addition and elimination. However, if we go back to the equation where we had a, b, and c times our factors of the denominator, then we can see that we have a times x minus 1 the quantity squared. That means if we let x equal 1, then, and that's everywhere we see x in the equation, then we'll have 3 minus 5 on the left-hand side is equal to, since a has a factor x minus 1 the quantity squared, the a will zero out. B has factors 3x minus 1, x minus 1. Again, letting x equal 1, the b factor will zero out. For c, we'll end up with c times 3x minus 1. If x is 1, then that's c times 2. This simplifies to negative 2 is equal to 2c, and so that we know that c is equal to negative 1. Thinking of a number that will zero out the other factor, I'm looking now at c times the quantity of 3x minus 1. If we let x equal 1/3, then the c with 3x minus 1 will zero out. B is multiplied by a factor of 3x minus 1, and so the b term will zero out. On the left-hand side, we'll end up with 3 times 1/3 minus 5 times 1/9. And on the right-hand side, we have a times the quantity of x minus 1 squared. If x is 1/3, then x minus 1 squared is 4/9. So we'd have 1 minus 5/9 is equal to 4/9 a. That would lead to a equals 1. Now, folks, if a is 1 and c is negative 1, we can use that information in the equation that says 0 is equal to a plus b minus c. 0 is then equal to 1 plus b minus a negative 1, which means that b is equal to negative 2. So our numerators are 1, negative 2, and negative 1. Those numerators had respective denominators of 3x minus 1, x minus 1, and x minus 1, the quantity squared. So our original integrand becomes 1 over 3x minus 1 minus 2 over x minus 1 minus 1 over x minus 1, the quantity squared. That whole thing is being integrated from 3 to 2 with respect to x, and so we throw in our dx. Now for the first fraction, 1 over 3x minus 1, if we let u equal 3x minus 1, then du is equal to 3 dx. So we need to multiply and divide that fraction by 3. That term will integrate to 1/3 times the natural log of 3x minus 1. For the second denominator, if we were to let, say, v equal x minus 1, then dv would be dx. Everything is fine, and so negative 2 over the quantity of x minus 1 will integrate to negative 2 times the natural log of the quantity of x minus 1. The third fraction is negative 1 over x minus 1, the quantity squared. If we let w equal x minus 1, then dw is equal to dx, and everything looks fine. But let's not blow past one important thing. We actually have, for that third term, the integral of negative 1 divided by a w squared dw. This is going to be handled using the power rule. We could express this as negative integral of 1 over, negative integral of w to the negative 2 dw. Adding 1 to that exponent and then dividing by the new exponent, but without making the actual substitution, is going to give us plus 1 over x minus 1. All of this is going to be evaluated from 2 to 3. I have it written here as from 3 to 2. It's from 2 to 3. So we end up with 1/3 times the natural log of 8 minus 2 times the natural log of 2 plus 1 over 2. Those values we got from substituting 3 in place of x. From that, we're going to subtract the quantity of 1/3 times the natural log of 5 minus 2 times the natural log of 1 plus 1. Those values we got by substituting 2 in place of x in the result of our integration. 1/3 times the natural log of 8 is the same thing as the natural log of 2 because the 1/3 can be expressed as an exponent on the base of 8. In the next term, we have minus 2 times the natural log of 2, and then plus 1/2. We'll just keep writing stuff. Distributing the negative, minus 1/3, natural log of 5. Folks, negative 2 times the natural log of 1 is 0. And then distributing, again, the negative here to the 1 at the end, we have minus 1. We can express this as combining like terms. Natural log of 2 minus 2 times the natural log of 2 is negative natural log of 2. Minus 1/3 times the natural log of 5. Plus 1/2 minus 1 gives us minus 1/2. Now we could leave it like this. We have a bunch of negatives and that is okay. We could also, though, take the negative leading coefficient of natural log of 2, turn that into an exponent, and express negative natural log of 2 as the natural log of 1/2. The rest of this is going to remain unchanged, so natural log of 1/2 minus 1/3 times the natural log of 5 minus 1/2 is how I choose to express the final answer.